Hi all, I'm Vijay Jithani. So in today's session, which is session 4, we will basically cover exam prep for caching and application insight. So let's see what we have from an exam blueprint. So if you see from an exam blueprint, we have caching, which basically we covered two of them. One is for Redis cache and another is CDN. Now if you look at basically in exam, you will get the questions around the concepts, the tiering, what kind of the whether you go for an enterprise versus standard. So those are the questions they will basically test you on caching. Similarly, there will be questions around which solution is best for a specific purpose. Like you will get an yes no kind of a questions around that. Similarly, from an application insights, it will be more of how you work around or how you instrument the application insights within the application. So how you basically work on logs, how you basically configure them, how you monitor them, and also at the end, obviously, you need an end-to-end troubleshooting mechanism with the help of some kind of testing along with the logging and a query capability on top of what you have out of box from an application insights. So if you see the blueprint, it basically talks about an expiration policies, how you implement the different caching patterns and the content delivery network. Similarly, from an application insights, you are basically going to configure them and monitor whether it's a real time or using logs. And finally, you do the testing and what kind of the tests are available out of box with the application insights. So with that, I think we will get started, or we will deep dive into the concept for caching, and from there onwards we will get started. So let's start with the caching. Now first of all, what exactly the cache is and how that helps an application. Consider a web app which is running in the production environment, and at the back end you have the SQL database. So if anyone wants to access any of the web application or the HTTPS or HTTP, whichever you can say, you have to always go and fetch the data from SQL server, which is the backend database. In case these queries, whatever we are reading from a SQL database, are more of a static nature, that means we are just, for example, you are just pulling the product catalog or something from the database. So in that case, basically what we do is, instead of hitting directly to a SQL database, we bring the intermediate tier, which is nothing but the caching layer. With this caching layer, we can cache most of the static data. Now, once we do that, what are we actually trying to do here? If you cache the data in obviously when you are saying caching the data, it has to be memory. It cannot be the storage, because then only it will be faster and provide you the right performance you need. So the first requirement for caching is it has to run in the memory, or in other words, it has to be equally fast to the memory. Okay, so that is what is a requirement from any of the caching database. So with that, we are solving first of all the performance, and then if this website is very busy, we are offloading some of the reads from the cache, then actually going to the databases. So that is how we are bringing the data closer to application and reducing the latency and contention. Obviously, we are handling some of the requests from the cache, hence we are also helping with the contention. Okay, so this is the brief concept of caching. Now, what we have out of box from an Azure Cache for Redis. As I already said, that this is more of a in-memory database, and it improves the performance and scalability, because out of box you are trying to access, or I would say offload the read transactions mainly. It can even have the write related, but for us, I think speeding mainly is concerned, or performance is mainly measured more from a read per se. That is the reason we say that we have a cache of the original database, or we say a subset of the original database. That is how we improve the performance and scalability. And obviously this will be a large volume of the data, and the website will be very busy. Hence, keeping in a server memory obviously helps us then accessing from any of the storage layers. Also, this brings from a networking aspects, if you bring anything closer to an application, so there will be low latency, and you will be able to access, or the application will be able to access the database or data with ease. Okay, so this is the concept of how Azure Cache for Redis works. Now let us understand what kind of these service tiers are available to us for consumption. So I will just increase the size bit so that we are able to read it properly. Yeah, now, so first of all, if you are trying out in the development and the test, then you should go with the basic tier. In this, basically you have a memory size from 250 MB to 53 GB. That is what we have from this particular basic. Also, you will be able to have the private link. Now, the reason for private link is most of the PaaS services, including cache, they are actually accessible on the endpoints which are publicly available. But however, with the help of Azure private link and a private endpoint, we can expose them using the private endpoint or network, you can say, so that we don't have to go over the public network. Okay, so that is the basic which you see in all of these tiers. The other tier which you can have use is standard. Now in this tier, basically, if you see, the memory size remains the same. Availability has, now we are being able to provide an availability because it has a primary and replica model, and you will be also able to have the private link for all of them. And finally, replication and failover is available in standard, because now you are having a replica of this particular cache. So there will be one instance for your primary and another instance for replica in the standard. Now this is good for your basic small to medium website, or where the load is moderate. However, if you see in terms of if the database, or if you see the product catalog, the example which I was giving for a shopping website, it can be very busy website, and it can have the data in GBs, even to a certain extent it can go even in the terabytes. But considering as of now that it is in GB, we have to scale ourselves so that we have the cluster available. So clustering basically starts from your, what you see here is from the premium tier. Here you have minimum 6 GB to 120 GB. The availability remains the same. However, you should be able to have a replication zone redundancy also available as part of this. So from Redis, data persistence, Redis clusters, virtual network, and geo replication. So these are the things which you see out of box available from premium. As we move to the enterprise, now this is completely different than what you are seeing in the premium, because here now it is using, till here you are using an open source version of Redis. From enterprise, this is more of its Redis modules also available to us out of box. And if you see, the capacity is increased, the resiliency and availability has also increased, along with whatever we were seeing as part of our cluster. Okay, now you can have the active instances. Also, you should be able to use the Redis search, JSON. Now what are these? Redis search is basically within your data sets you can now search, because now you are using the Redis enterprise, which is the customized version than using an open source version. Similarly, JSON, this is kind of a data set or data model which you can use from the Redis JSON. Now you have Redis Bloom. This is more of a prediction of whether a specific keys or subset of data is available before we query that. So, and time series, obviously the you can say the live traffic kind of available along with the. So these kind of right from search till time series of flash, these are only available from an enterprise or enterprise flash layer from a Redis per se. So in an exam, you will be tested on basically what to use versus from basic to an enterprise flash. So you should be able to, based on the criteria they are asking, you should be able to answer that particular question. Okay, so this is what we can do out of box for the Redis pairings we have. Now till here we covered the basic of what a Redis and why we require Redis, and then what kind of the tiers we select based upon the criteria. What about the use cases and how do we actually make most use of the Redis now, or cache I would say. Now if you see from a caching aspects, you have the data cache, you have content cache, session store, job and messaging queuing, distributed transactions. So you can call them as a Redis patterns, or you can call them as a use cases. Now why specific these patterns? Because each one have the different criteria. Now for example, data cache, this is mainly of offloading the large load from a database into cache, or I would say a subset of data from a database into, so that we can serve that content from cache. However, if you want to have a content related cache, now content, when you actually build your website, you will have a static content like headers and all those footers, something which will not change, but there will be something which is a live data, which is continuously changing based upon the time. Okay, or you would say it requires a frequent updates, so that for that we call it as a dynamic data. So in these it is called a content related cache, where you actually populating the website static content from the cache and dynamic content at the fly in the real time. Other thing which you can think of is again the example from the shopping product catalog, or whatever you are doing shopping on the commercial websites. Each particular session, what you are doing within particular session, adding some products to your shopping cart, till that time it remains in the cache until you commit that, or until you order from that particular shopping website. So this is very important than having a user cookies, which can become very bulky at times, and this will help us even populating them next time when the user logs in. So with this help of the session store, this will provide the data for that particular, or for that particular user. Now other thing is job and message queue. Now in case of distributed transactions or some task which are running asynchronously, we can actually add them to queue until that operations are completed. Okay, so what do we mean by that is, we may have a different, like say fetching the pricing information from the product catalog, or something on fetching some offers or something of that sort. So those kind of the tasks can be queued and will operate independent to what the website is serving for the users. So this will help us actually queuing the respective task where the hits are specific for specific and towards that particular product catalog, as an example. Okay, and last is a distributed transaction. Now what kind of example we can take here is, say suppose you have already have the whatever you want to purchase in the shopping catalog. Now once you confirm that you confirm you ordered, it should first of all take you to the payment, confirm the payment, then again send the request for shipping. Similarly, it will also provide you the confirmation mail. Also you should be able to have the tracking system enabled for once that is shipped. So these are different actually transactions taking place, which are actually to be if either it should, from a transaction aspects, if I have placed my order, these all actions should be taken place. So that is where you can consider a single atomic operation which will execute the different commands in the case of if we are doing the purchase on this particular website. So these are the distributed transactions which you can consider, which will be taken care by the backend data store from a single atomic operation. So these are the Redis use cases, and depending upon how you want to use them, for what purpose you want to use them, you can choose from 5 of them. Okay, now considering how do we implement the cache, because to be frank, irrespective of whatever patterns we have to also make sure that the caching implementation has everything possible from a redundancy aspects, from an availability aspects, and how do we actually do the caching, how it should be taken, how it should be serving the most recent data. So for this we have these considerations to be taken place, or you can consider this as a best practices. Now decide when to cache the data. Now if you see, like from a database standpoint, if we really want to have a subset of that, then obviously which specific aspects or which particular database we want to cache, or which subset of database we want to cache, that we have to decide. So that is where is this particular is about when to cache, and where it can really have the more of a read transactions, when we can really offload them. So that is where this will help us. How to cache the data effectively, this is more on, as I said, from the depending patterns, we can determine that whether this will be really useful for caching or whether it can be served directly. Now, for example, I would say when you are doing the transaction for the payment, it has to be instantaneous. It cannot be done from the cache. Okay, so example here is, if I am on fetching some from the product catalog or the inventory, that makes sense for me to actually use the read transactions from them than to the actual database. But when it is actually the transactions, then there I have to deal directly with the data store than actually dealing with the cache. So this is how I have to cache the data effectively, so that I am able to handle the operations in most effective way. Okay. So cache highly dynamic data. So most of the time, what we are in the case of a shopping cart itself, when the users around, so whatever is changing during that aspects, we can really cache those dynamic data for that particular session. Similarly, you can consider this dynamic data also to be some of the real-time series data coming from any particular the inventory or from the logs which we are feeding into. Okay, so this can also be the highly dynamic data, mainly, but this will be for your websites, but then you can always have the different use cases. The other consideration we have to make is a data expiration. By what time the data in cache needs to be invalidated so that it can fetch. So that needs to be taken care depending upon what kind of the data is. So suppose if you are if you know this product is getting updated weekly, or maybe twice a day, inventory is updated twice a day, or maybe within a week, or within, so that is how you have to manage the expiration in cache. Okay, so similarly, invalidate then the client side cache is the another, where you have the local caching on the client machine than actually on the server. So you also have, so that they are able to fetch the recent data. Concurrency in cache is more of how actually we are trying to make the instances, like say suppose caching instance in case of the cluster, they all should be providing the same data. So that is what is meant by concurrency in the caching database. High availability, scalability, and in performance is depending upon the hits, how you are actually able to scale yourself, how are you able to restore you back from the catastrophic event. So those all things will be actually taken care within the high availability, scalability perspective. Now at any point of time, if you have seen the cache, it is more of a data store, right? So you actually have a subset of data in the form of any data sets in that cache. So it will obviously have an eventual consistency versus the strong consistency. That means depending upon how the replication frequency is, that there will be still some lag. So we always have them as a eventual consistency than actual strong consistency. Strong consistency is obviously required when you are actually doing, as I said, transactions for a payment. There you cannot have the eventual consistency. It has to be strong consistency. But in case of the other product catalog, inventory, or other things, you can have a eventual consistency or replication, so that there is no duplicate payment done from by the shopping on the shopping website. Similarly, if there is a product inventory, we can so if it is lagged by some microseconds or something, we can tolerate that. So these are the considerations we have to take while we are actually designing our Redis cache. Okay, and finally protecting that data. Now if I am actually serving the data from cache, it has to be encrypted, and obviously if I am frequently accessing a subset of data, then it has to be partitioned accordingly. So that is what is main. First is an encryption, that everything will go will be encrypted. Every data what is be accessed by application will be encrypted, so that there is no man in middle attack. And the second thing is obviously it has to if I have to protect it, then I have to think about the encryption as well as the how we are doing the transaction. Okay, so I will just pause here for a while until we move for the other session, other module. Also remember, whenever you are having these considerations, if you are trying this with any of your application, make sure you understand the caching pattern you have to use. Unless you are aware of the caching pattern you want to use, I think the considerations will accordingly have to be taken care of during that implementation. So while I show you the portal walkthrough, I think you will understand where and how this all things are actually fitting in. But meanwhile, I think you can consider that from concept aspects. First of all, you should understand why the cache is required. Then from the tiering aspects, if you see that we have clearly covered which specific feature sets of functionality are available in respective tiers, and then we have covered the patterns, and finally we ended up on the considerations for the caching implementations. If you are through with this, how you are actually implementing caching, I think you should be able to make most of whatever the questions you get in exam. Okay, now to show you how a specific Redis cache needs to be implemented, let me open up the another tab, which is nothing but the documentation itself from an Azure aspects. So here, if you see, I'm just increasing the size here as well. How you're actually creating that, and this particular step-by-step article will actually also provide you the respective implementation for cache, as well as the what are the information you need before you can actually create the cache. So first of all, obviously you need a subscription, you need to have a resource group, a unique DNS name, and then you have to select a location and cache tier. Now again, the cache tier, as I've shown you from all 5 caching tier aspects, you need to remember or need to take in consideration what is your need, and accordingly move with the standard, premium, or the enterprise tiers. Okay, and as you have seen, we have the networking integration as well. Also you can have Azure private link in all of them for accessing. So remember those things while you are actually creating them at the runtime. Now from a networking aspects or selecting the caching creation, you can select in advance basically your the version. Also if you want to have an integration along for the Microsoft Active Directory, which is nothing but Pentra authentication as of now, and networking as well, you can select based upon you want to have the integration with that or not. Okay, now if you see from a premium caching or configuration aspects, the you also have the other Redis related consoles. So you will see that as well. So while you create this, you just review and create this, and based upon the depending upon the tier you have configured, you can see through all of this in this particular article. That means you are actually going through each one of them and doing the settings right from an authentication, scaling, cluster sizing, persistence, identity, everything you can see in this particular article. That is the reason I have just kept this for your reference, so that while you actually configure your Redis cache on your own, you should be able to help you what are the different roles you need to configure, you want to tag. But important thing here to note down here is in these you have a console, and in Redis console is more of a command line. Okay, so you should be able to run the, as I've told you, you can run the search command, you can also query within those console if you are using the enterprise version. And apart from that, I think what I want to show you here is how you can actually have the settings. Okay, so if I can show you what kind of settings right from an authentication aspects, you have a primary and secondary key, and it is similar to what you have the database connection strings. Okay, so remember this is a one kind of database itself, which will help you to actually do your job. Okay, also in case of Redis, you will have the one is the Redis database itself, and another one is the you can have the append only log. So that is nothing but instead of having the snapshot or the database pattern, you can actually have your caching in terms of that all can be replayed without any data loss. That means we are providing a redundancy to the incremental transactions which are happening at the runtime in the log, so that we can replay them during any catastrophic event. Okay, so you are seeing here from an authentication aspects how you can enable them. Now this is the example how this is being configured on the other settings. You can see from an access ports. Okay, these are actual configurations you can do a walkthrough, or maybe while you implement that you can just go through each one of them and configure the TLS version. Now minimum by default is 1.2 for the newest, and if you are using any older, I think you will have 1.1, but soon and later you will have to upgrade from TLS version 1.2 and above. Okay, similarly there will be policies of how you have to keep. So that is the reason I think you can use the caching policies here: maximum memory reserved, fragmented reserve. So these all things basically will help you to keep the cache or I would say the invalidate cache and fetch the new content based upon that. So from exam point of view, I think they will not get more into detail of all of them, but I think if you know them will be better. So I would suggest actually read them through. Say suppose volatile LRU is the default. It removes the least recently used key out of the keys with expiration set. So basically if it is not being used, so this is what you can read through all of them. Similarly, removes the least recently used keys for all keys. Okay, so depending upon what kind of the mechanism you're using or the policy you're using for keeping the data in memory, you can select from all of them. Okay, so there's also no evacuation. That means it if you attempt to insert any data or override that particular key or value pair, it will give you the error. So that is what is meant by the no evacuation. Basically with each of these memory policies, you are actually taking care of an expiration or invalidating the content in the database. So there is quite a good documentation around how you want to keep and what minimum and maximum you want to keep. So that is what I think you can read this through from an article. This will help you also to configure whether specific events are happening and you notified for a specific key to be validated or to be invalidated based upon the requirements or expiration policies. And scale, I think I do talk about while I was going through the tiers. Depending upon how you want or what kind of the load you have, you can select from the premium minimum if you want to have cluster. If you are just going with the standard, I think you will get the master versus replica, so you are able to see what kind of the features that you are getting. Also, more important thing here is go for the what kind of the concurrent connections you are going to get. Now with all these tiers, they will have some kind of the concurrent tiers and what kind of the maximum. I think in our documentation we have already seen through what are the concurrent connections. If you see at the down, you are able to see maximum number of concurrent connections. It will give you out of box for the respective tiers. So just remember those things and you should be good to answer the questions in that exam. And while you create the cluster, I think from the aspects of what tier you have selected, you should be able to use the fully memory of that particular tier. So this is again on the shard. How do you shard the or how you distribute the data or cache within that particular database? Okay, so data persistence is again how you want to keep your data or want to I would say backup in terms of any catastrophic event. You have two forms. One is in form of database, which we call as a Redis DB or Redis database. Another is AOF, which is the append. Okay, so this kind of persistence we have for the Redis database or Redis cache. And on top of this, basically you can actually restore them the way you have your own backup strategy, like you have a daily, weekly and monthly backups. So you can consider them as a Redis database as a persistent, and you have an incremental backups as well, which takes care of the point in time or just in time transactions. So those kind of the logs you can have in the AOF kind of persistence. Also, you can combine those data persistent layers for you to make most use of the high availability in your catastrophic events. Apart from, I think what you have seen in identity, you can integrate Entra ID as well as use the manage identity. So that is what these particular screens are showing you. These are nothing but the updates. Okay, so as I said, this is the maintenance window you can have for the specific check the days you want, then specify them. So basically during that time, I think they will use the, you have to make use of the cluster effectively without any downtime. This is basically used for that. And if you are serving your content in more than 2 geographical regions, then obviously a geo replication and how you want to have the availability and consistency of a cache, that is what is taken in care of geo replication. Virtual network, I think we pretty much called out how we integrate or own if you're creating within your own network, which is supported from the premium cache. And private endpoint was available for all of them, what we have seen in our the tiering. And as this is on the private network, you need also have we can really only allow the IP address of your applications, then allowing whole range from your subnets. Okay, so that also you can take care of. Now apart from that, I think you should be able to see what is the naming convention, what are the ports you have been using, similarly how this is configured, which version, open source version of Redis you are using, and in case of an enterprise, obviously you will see that enterprise as well. And from if you want to really import and export the cache data, how you can do that, those all the settings are provided to us out of box. And finally, how do you have the respective maintenance work on this particular cache or cluster. Okay, so you can see clearly if you are using the primary and replica and these shards, how they are being used internally. So this article basically provides you end to end of what you can do from a cache on Redis. Okay. Also, you can get a diagnostic, advisory, recommendations. So I'm just scrolling it fast in interest of time. But I think while you configure your cache for Redis, I think I would suggest you should try for a standard versus premium. So just to show the difference, and then once you configure the premium, you can also check for how the instance for your enterprise looks like and how you are able to even. So there is a step-by-step instructions also given, so you can just go and have those particular reference from this article as well. Okay, so that's all from an walkthrough aspects for a Redis. So what we covered so far was, as a part of Redis cache, we have just seen the concept why we need the cache for a web tier. We have seen how a cache for Redis and which particular tiers it is available to us. Depending upon the functionality you want to choose, we will select appropriate Redis cache. What are the data patterns or application patterns you can use for caching, depending upon whether you're using it for data, using it for content, or using it for session store, or you are just using it for task-based queuing. And finally, the distributed transaction, which is the coordinated activity, depending upon what we have done as a part of shipping example, which we have taken, right? So once we come from the order, how actually the right from the payment and other task, how that will be shipped, everything needs to be tracked. Okay. Now, other kind of cache is the content delivery network. Now, this is different than what you see in the Azure Cache for Redis, because in Azure Cache for Redis, we have really seen from an application aspects how we are actually delivering or improving the performance. But here in content delivery network, it is more of a the unstructured data. That means the video files. You can see the static websites which needs to be available at respective regional locations. Okay, so that is where the content delivery network are being used. So you can see in overview that it delivers a high bandwidth content by caching content strategically. So it is different than actually improving the performance of the website. So remember, first one which we have done, cache for Redis, that was purely on how the websites can be performance of the website can be improved by providing a caching layer in simple sense. And here content delivery is more of for delivering the streaming data, your large high bandwidth data, or I would say a large files or static content which needs to be brought near regionally. Like suppose if we are scattered around the different regions in Asia Pacific, America, Europe. So if I want to deliver any content or video to Asia Pacific user, it should come from an Asia Pacific server versus the Europe server. And in case of obviously the failure, or then it can take the Europe content. So that is how basically this will helpful for us in handling the large, first of all, the data, and then moving to the other particular layers. Now, just to give you an example, in an example form, this is again like how a user is requesting the data. User is first of all try to connect to a edge network, content delivery network, and it will try to first fetch the data from the edge servers, which is nothing but the point of presence. Now there will be different servers depending upon from which location that person is fetching the data. If it is available, it will provided from fetch. If not available, the flow is considering that this is not available. Okay, data is not available in the caching server or a content delivery network. So it goes to the edge server, it does not find the data, it goes to an origin, and so on behalf of edge server requests that data, and origin server provides the data to the edge server, and finally it is provided to the user as well as the other users from this particular caching. Now This is how the flow is. First, if available, fetch from the edge servers. If not, go and fetch from origin, and origin provides. The difference is here we are doing most of a streaming or the static replication in a geographically dispersed locations. Okay, so remember this in terms of the CDN network. Now all of them obviously needs to have the certificates, a custom domain. So that is where we need to make sure we are taking care of security while we are providing this data, and it will have a unique URL. Similarly, for me to actually work on a respective use case, I will start with a CDN profile, which basically configures a bare minimum for what I want to really deliver this to users across the globe, and then create a respective endpoints to deliver that content across the globe. That means profile will actually have most of the configurations, okay, from the how the network is being configured. Endpoints are the way to deliver based upon the profile configurations. Now, if you see, CDN endpoint represents a specific configuration of content delivery behavior and access. Okay. Similarly, each of them can have, if you want to really combine based upon the different criteria, you can have multiple profiles. Okay. So that is what I was saying for a configuration. So limitations you may have based upon what kind of the environment you are or the tier you are. So these are basically the profiles can be created, endpoints can be based upon how you want to make the geographically dispersed, and finally the custom domains. So remember, in short, for this particular topic, I think you should only know how it is different from a Redis cache, when to use them, and finally how you have to create a CDN profile and the endpoints within that to serve that content out of the CDN. So this is bare minimum you have to remember, and there is no, as such, there is nothing more here from a developer configuration aspects which you have to remember. Just remember the products are available in three form. One is Azure CDN from Microsoft itself, another is from Verizon, which is now the Azure. So here also you can actually create the till what time the cache will serve the static content, or what is the frequency it needs to be invalidate the data, and it basically follows the push and pull. I would say if it is not available, it is going to pull from an origin. Push is something I am purposely making sure that at every day, for example, I want to invalidate and make them fetch the complete new data, but that purely depends upon the volume of data you have. If you have a terabytes of the data which you want to do, you can't do it regularly. Only when that content changes, that is the best thing you have to do. That is the pull mechanism from an origin server. So that is what everyone follows. But whether you do the pull or whether you do the push, purely that is in your hand, how you want to pull the data from the cache. Okay. So the example also tells you, like if you are using for a Microsoft tier of CDN, then you have three options. Basically, I would say you are only able to manage your sites without without using any query string. That means here you are ignoring query strings or bypassing cache for query strings and having every unique URL. So basically, in short, these all three things say that you are managing everything at the site level. But if you really go with the other, you can also, for Azure, you can also manage the caching at the directory level. And that means at the sub application, or I would say a virtual directories within that website. Okay, so you can have caching rules based upon the query strings as well as the unique URLs. Okay. So that you have to remember from the CDN cache per se. So other thing, as I said, invalidating the data is the important thing, so that you don't provide the defunct or the data which is expired. It has to be fresh. Similarly, you also need to make sure that you are pulling the right or configuring the right policies of updating the data at right time. So for a web delivery optimization, the caching or time to live is only 7 days, even for the static data. Similarly, large file optimization, that means at the end of the day, if they are in the terabytes or maybe some GBs, you want to keep them at least for a day, because otherwise this will choke up your bandwidth. Media streaming as well, optimizations, if those are not updating quite often. So 1 year is what has been seen. That means what you are being streaming through your channels or something, that has to be a maximum gone for 1 year. So basically these all expiration policies you can consider for getting the right data, or I would say fetching the right data at the different geographically dispersed location. Okay, now just see for contain updation. So in normal operation, edge node will serve an asset until TTL expires. Okay, so whatever you have seen in the LI's case. So if it expires, then obviously the client make a request to the client make as same asset, but it does not find in the edge servers. So it is going to fetch from an origin server. To ensure user always receive the latest version of an asset, consider including a versioning string. That means what we can do here is, say suppose we are providing the data, and if there is a new version available, old data will be available on version 1, so that will be a unique URL. Similarly, the new data will be on version 2. That way you can also solve the purpose of old versus new delivering from the same edge network. Okay, so that is how you can get your contain updation using that. Also, as I've already told, you can also purge the contain so that every time based upon the bandwidth required, you can actually refresh the content daily, weekly, based upon how you want to cache to be available, or maybe the those particular files to be available from that network. Okay, so these are the some mechanism. Obviously geo filtering, you need a standard and premium and above that. So I would say premium and above that. But ideally you should be able to do the based upon how you're delivering your across the globe within the regions, and accordingly set their respective policies. So with that, I think we covered the first part, which was on the caching. Okay, and while you configure them, I think you should be able to make sure how you configure the cache considerations and expiration policies, caching patterns, which I have shown you how and what kind of encryption and expiration you will have, and obviously the content delivery network is nothing more on from how you configure the edge servers along with the endpoints and the profiles. So these three topics I think basically covers your first part for caching. Now we are going to do the application insight. Okay, so let's look at the application insight. Now, first of all, application insight, why we really need that. So we know that we have a web application or the web APIs running. So for us to actually monitor that every transaction is actually meeting the requirement of performance, I would say meeting the performance requirement from every layer. Like say I'm going from a front end, from a client layer to a front end, then from front end to the middle tier, from middle tier to the back end. So in all these layers, I am dependent on some kind of a services. So that is what you see. I have the front end, then I have some back end APIs, which are calling the dependent services, which actually stores the data for me, and all of them are actually able to integrate some kind of monitoring. So that is where I call this as instrumenting application insight. That means I'm actually, with the help of agent or SDK, I'm embedding the some agent kind of functionality so that I can monitor the logs or get something real time. These are the only two available methods. That means you can get a performance metrics real time versus you can store all the logs and do the actual troubleshooting or some kind of diagnostic on top of that. So engine here is an application insight. It can provide me the alerts, it can provide me the dashboards, it can also help me integration from development aspects. It can help me whether the respective APIs are performing well within the performance boundaries. And finally, I can really have those logs exported in some kind of warehousing or the further deep dive into the troubleshooting aspects. So what I'm trying to say here is, if you want to really instrument it or inject the monitoring, application insight is used for a web related performance monitoring. Also, I can get the data, I can troubleshoot and diagnose if something is going wrong. How we do that? Let's go in the next topic to see that. So an insight, how the components look like. As I told you that first of all, I want to instrument. That means I have injected the application insight agent or some kind of custom code to get the monitoring data. Now this data will be available obviously in form of live metrics versus the log, which is nothing but the telemetry. If it is a telemetry, then I will get some kind of a log store or log analytics, because this has to run on the store data. And finally, whatever I've shown you, I can investigate in an application map, getting real-time metrics, or even do the transaction related search. This is more of a real-time what you see in and out within an application. But if you also want to have an alerts or incidents being created from that, you can also have the alerts and metrics created, and also have the diagnostic settings, because in these, when we want to deep dive and really fetch what is going wrong, you all have to enable the diagnostic so that full level logging is enabled. Okay. Apart from monitoring whether the performance is good and all the users are able to access that real time versus logs, there's also another layer, which is how or which specific pages are important, or which are the most hit pages. So those all data you can get from the users. That means this particular page is more important. Say suppose if you are populating any particular the charts for how the stocks are performing for any particular, so those kinds of information, which stock is which stock is more hit, or the more hits on a specific page for a specific company, you can actually make out from them. Similarly, if you're in a shopping website, then I can say which product is most being used, or which product is most being accessed from the commercial websites. Those all things I think you can get out of application insights. Remember, this is an web and web API layer only. It cannot monitored or inject within your desktop apps. Remember, this is a web layer. That is the reason if you see our instrumentation was only to the web layer, not to any of the services which does not have the anything on the HTTPS or a web layer. Okay, remember this is only for the web tier, or the most of the applications who use the web as the mechanism or API, some integration in form of the web. Now whatever we have been talking through, this is what you have from a diagnostic or whatever you are available out of box. What you can do, live metrics, yes, we can get most of the activity in real time from the web app or whichever whole solution where we have instrumented application inside. Similarly, from an availability aspects, I can have a availability test configure for them. And if I want to really call out if something is being failing, I can really create a work item or request which have integration with the DevOps as well. And who is using, what is the hits, which are the mostly hit pages, and all those things I can get from the users. Detection based upon the experience you may have, if any particular layer, middle tier, front end, or even the back end, which is failing for any reason, till the API, where you have seen the API being integrated, you can actually make out from where where it is being failing based upon the logs you have been provided from an application aspects. Okay, so that you can get that. Application map gives you a whole view of I think we will see this in a more depth in the next topic. Bear with me for that. And distributed tracing, as I've already told you, if you have done a shopping transaction, that means you have confirmed the order. The next part it has to go is take you to the payment along with the shipping information. Similarly, obviously, how you can trace that. There are n number of tasks you can consider as one activity, but there are different tasks to different teams. So that is where a distributed tracing is important. Okay. So these all things I think you can consider for monitoring and diagnostic from an application insight. So I will just pause here for a while so that you can go through this. Now, mostly if you want to really have the deep dive of your the data, you will require some kind of a log based diagnostic. So this is more handy when you really want to troubleshoot for every event that is being taken care within the for or something going wrong with the website from a performance aspect, for something getting failed. So that is where you have the log based metrics. Now there are two metrics, one is log based and there's a pre-aggregated metrics. Difference is if you see the application insights, now this collect events as logs as an analytic and diagnostic tool. Use logs to retain complete set of events can bring great analytic and diagnostic value. Collecting complete set of events may be impractical or even impossible for application that generate a large volume of telemetry. So this is more of a complete log, you can say, and pre-aggregated is more of a stored in for a specific time. So pre-aggregated means for the time interval you can have actually the window, or the aggregation happens for a minutes or hours, you can say. That particular or combining based upon the data you want to skew. But in this, obviously, you will not have the complete data. You will only have the data which is aggregated for the time interval. But in case of log, you get a complete data. So that is where you have to select from whether you need a performance. Say suppose you are just monitoring the CPU and memory level. Unless that is having the frequent problems, you should go with the pre-aggregated metrics. If it is having the performance is a problem quite often, then you should go with the log based metrics for the selection of that. Now, how do I enable an application insight? Obviously, as I've shown you the instrumentation, one is I do have an agent, or I just have to toggle the switch within the services I'm using within Azure to do that. Other way is I'm customizing this for I can really have a SDK way of integrating, because I have the different requirements altogether. So in that case, I will have the SDK integration with my development environment. And whether I want to have a distributed tracing as well as enable depends upon the transactions, or whether I want to really trace them end to end based upon transaction you are actually monitoring. In case of the example, you can take again, once you are placing the order till the order is received by your user, you have to have the distributed tracing so that the order is completed successfully. Okay. Now other part is consider the availability test, right? Now at this point of time, URL ping test was actually started. That means this is for availability test which we had. This was initial, but this was only for a ping. That means if this website is live, that means listening on HTTPS port from a publicly available endpoint, this will give you green. Otherwise, it will give you a red. But what requirement was also to include an SSL validation, whether the certificate. So that is what is the requirements for most of the website from so that it is not a fraud and we are able to access the proper websites, or I would say a trusted websites. So standard test is what will replace the URL ping test, because this includes an SSL certificate validity proactive time lifetime check, what are the different methods you are allowing based upon the your role base, whether you are only allowed to do the get versus head. So those all things available test you can do on top of the exposed APIs, I would say publicly. But if you want to really try out something custom, then obviously you have to go on the track availability method. You have the different SDKs, or I would say a functionality available for you to actually embed this in a form of the code. So you can actually have that custom code for your for track availability method, which you can take care within your development. Okay, so remember this availability test and how you do that. Now coming to the last part from an application insights is how do you actually see this particular map. Now in this particular, let me try to increase this a bit. Now this is nothing but an application map. Okay, so in this example you see the availability at 25%, and then you have only one instance running. Okay, and there is a 12% you can say a problem for this particular node, which is Fabricam pod, and it has that a dependency dependent data taken this. So you can consider this as a backend. The backend, this is a middle or I would say a front end tier from which you are trying to measure the availability. Okay, so availability will give you the what is the availability of this instance, and depending upon the availability as to your configure. Similarly, if there's any problem, you will see the latency. Okay, this is what kind of the time is taken from the client to reach this instance, production instance, and what is the time required to reach the backend. Okay, respective services. So this is storage, this is a SQL database, this is again the queue. Okay, so based upon the pattern you are using or what kind of the data you are fetching, you are actually trying to trace a end-to-end performance with the help of application map. Okay, now with this, I think I was just trying to show from an application aspects, you can let me come down. So with this, I think you have the actual layout or trace, I would say, from how you actually tracing the availability from the node to the backend. Now it can also show you, if you drill down in respective nodes, it can also show you the what are the failing requests, whatever you see in the red, what are the failing requests. Now as this is an HTTP or API calls, you will see get post. Similar is the case while you see from the request by name. So ideally the first part gives you the failures by name. That means depending upon which kind of the request or APIs are failing, and here you are trying to investigate the failures. Here you are trying to investigate the performance. That means the latency part. Now, if I want to show you in more in depth, I think here is again the article which you can follow for an application insights as well. This is a distributed application triage. Okay, so I am just taking you directly to that. This I have taken from this example or screenshot I've taken from this, so that you also get a walkthrough of exactly same. Okay, so this is an example I was trying to show you. If you see from this example, we were clear that there is an availability challenges, what is green versus red, and how the latency is for end to end. Okay, now if you click on investigate failures, they have also dig down even detail into this. So this is what the graph will look like. If you click on investigate failures, it will take you to the, first of all, important thing is to see the dependencies. These are failures, and if there are any exceptions happening, this also will give you an exceptions, also give you the response code where you are seeing these failures. Similarly is for the performance. If wherever you are showing the latency, just see the latency level, and if you click on investigate performance, it will give you the graph similar to this. So that way I think you can really make out what is taking more time, whether I have to optimize the queries with the backend, or is there any exceptions happening which is not being handled through your application at the API level. So those all things, if we make out, I think this pretty much gives us everything we need to look from an application investigation aspects, right? So if you even go further into that particular get employee create, which was showing from a transaction aspects, it will give you what kind of the exceptions it is having. Similarly, if you can also run the queries, log analytics queries on top of that, that means for the timestamp greater than 12 hours, I want to see, okay, the time chart for the response. So in this, basically, you will clearly see the respective duration, request duration versus timestamp. You can also see the alerts. As I said, you with these step-by-step documents, you can really go through and validate whatever you have configured. Also look through the respective codes. Like if you have embedded within your application, you can, this is for .NET, you can look for Java. Similarly is for Node.js, JavaScript, Python. So ideally everything makes sense from how you are actually trying to get the telemetry, how you actually see. One important thing I want to show you is a cloud role name. Now based upon what functionality you are designing, it will have the different role name and what APIs you are trying to integrate. Okay, so ensure while fetching the telemetry, you have the appropriate naming convention configured before you can actually fetch them or understand the telemetry from an application inside. So this is very handy, and from an application map per se, I think it gives you end-to-end view of how the instances are performing, and wherever there are multiple instances as well, it shows you the backend layer, the latency, the red and green provides you. So pretty much helpful in terms of whichever, whether you are working with the microservices versus with the application code, unless and until you are using the some kind of the layering, or I would say an API get fetch methods, uh, or I would say the REST based methods, you should be able to do the monitoring on the application insights. So coming back, that's all we have for this session, and probably next session we will cover the event hubs and all the application integration gateways and everything, which is our last session 5 to complete this exam preparation. But to summarize, I think we covered pretty much on caching layers, which was Redis cache and the content delivery network, and application insights. We deep dive into why we actually need an application insights, how we want to instrument that, and being the web layer, how actually you can have the different configurations, or I would say real time versus a log based metrics, how what kind of the dashboards or what is the look and feel in application map versus the live metrics. Those all things you can go through step by step. So that's all. Thanks for listening to this video.